By the way, I already uploaded to YouTube, but I forgot to post the link up. Okay. Yeah. So what I'm talking about last time is about there is a one very important concept. Why TCP? Okay. This is a reliable TCP server, right? Why the TCP reliable server can handle multiple connections? Usually, it's because you call multiple accepts. You call accept multiple times. Okay. So once you call once, then accept system call will see, is there any people waiting? So if there are 10 people waiting, you call it once, it will handle any one of them. And then there will be 9 people waiting. You call second time, third time, until you call 10th time, then you will handle all 10 guys. Now the problem is, if you have really the 10 guys, so you will basically create 10 different, we call accept ID. FD, I want to say IP. Accept FD, accept file descriptor. Okay? So is it useful that we have let's say I go on, I know that I will have 10 clients coming, I call 10 times and loop it for 10 times, then I will have an array of accept FD. Is it useful or not? I will say that it's totally useless unless you're doing broadcasting. Broadcasting means that every user will only silently receive what you send, okay, and they will finally receive it, okay, it don't react to you, okay. So as long as this is the case, okay. Now what if this is an interactive process, just like I give you the sample program, simple network.zip. There's an interactive. What is the meaning of interactive? I am a server. I accept your client connection, and what's next? Next is, after I accept your connection, I will go on to wait for your response, right? Do you understand what is the difference? The difference between a broadcast, like where is broadcast? So maybe a YouTube, okay? YouTube is connected to the server. The server job is very dull. You ask me for one thing, I just push the file to you no matter what. Okay, I keep pushing to you, and do I need to allow you to give me any response? I don't need to, right? Your response is give me something. Then I stream things to you continuously, non-stop, until I finish sending the process. Then I say, okay, stop the connection. Okay? So this is the model if you are doing broadcast or just only someone send a connection to you and you always know what to do. Now, what if you don't know what to do? Just like our example, the problem comes. Imagine here, now remember this figure, okay? Once I call accept once, I will have one accept ID, accept FD. So remember this, I'll jump to the code now. Remember the figure. Now I go to the simplified multi-process version, the simple version. Now the simple version, look at the code. Okay, this is where is the while loop? Okay, while loop, main loop here. Okay, this is a while loop. Okay, this is start of the while loop. Now the while loop only include the accept once, right? So you expect that the while loop all the way go down. Oh, hit accept. Accept is blocking system call. So I wait for connection. Let's say already 10 guys there. I accept once. Go on. That means that it will unblock. Go on. I have one accept FD. Very good. Go on, go on, go on, go on, and suddenly I found something. I found read here. Okay, I found read system call here. So do you remember what is read system call? If you're reading from a file, then you retrieve things from a file. If you're reading from a network, that means that you wait for a response from the client or on the other side. I don't matter. This matter. It's client or server. It doesn't matter basically. So here I just waiting for a network response. What if the network don't give you response? Just like I just asked you to try. Just connect to me, don't give me any response. Then what will happen? I will be frozen here. Okay, I will frozen at this point. Never return. Now what will happen? Do you have a chance that to go to the end of this infinite loop and going back? There's no chance because you are being stopped at this recall. Okay, so now remember back the figure that I want you to remember. The figures only give you the chance if you don't call this read. You don't call this read. You always say write. Okay? the while loop say that, okay, let's start, I accept of connections, then I write. I don't know how many amounts, let's say, this is not the read call, this is write call, write 1 GB. Okay, 1 GB of data, send it out, push it out to the network, and then it return. Usually write is fast, right? You know, write to a file or write to a network, usually it's unblocked, okay, immediately. Now, after it's unblocked immediately, we'll go on, and can you find any blocking system call? So there's not a blocking system call, preenf not a blocking system call, this is not, I guarantee you, also preenf is not a blocking system call, and then close. Okay? So then, if that case, you can use this simplified server version. If you ask for a response from your opposite side, now the problem becomes very complicated. How complicated is because you wait for the read system call to unblock you. So I designed in this process, I designed to use a fork, okay, and make the child process to execute the part that I just copy and paste from, yeah, don't need to run, okay. Yeah, the child process copy the read, okay, and all the things that you have just seen in a simplified version of the program. Now, what will happen now? What will happen now is that basically I have a multiple processes, okay. Wait a moment. Wow, very slow. Okay, good. So basically, I'm having something like this. Okay, doesn't work. Yeah, I know why. Okay. Hey, it doesn't become a pen. This software sucks. I suppose it become a pen and then we to draw. Okay, so forget about this. Let me use the laser. Hey, wait, come on, baby, move. Okay. So, but basically, this is a wrong model if you are asking for interactive action. So, what is the right model? The right model is like this. Laser, okay. The right model is like this. After you call accept, you call fork, and put all the application logic. This is a new thing, okay, whether it's a new thread or a new process, put all the logic there. I don't know the logic is about interactive or not, okay? If it's interactive, good. I let the process to block for that client response. And how about this old process, the parent process? It will still be blocked, but blocked because of accept system call. Understand? So that's why I always say that the 4430 is an advanced version of operating system. Okay? You will know why I teach you forks before, okay? Because now you know why we need it. Basically, Chrome, inside Chrome is doing something like this. Chrome is a multi-process browser, okay? It is doing something like this. You ask for a new tab, I fork a new browser for you, and after that browser is being created, I listen to others' response like the network or the keyboard and mouse or so forth. Okay? So, or threading version, there's a threading version of browser, so it is also doing the same thing in order to boost the parallelism. Okay? So that's why I create this this new process, the fork version of the process. And where can you find I do the fork? Very simple. After accept, okay, after accept, I do some accounting jobs. Okay, I count how many client, and then immediately I call fork. Okay, if fork is equal to 0, so that means that it's a client process. I will call a child function. Okay, this is a function for the child. Okay, and inside the function child, of course, I will call exit at the end, so that the child process will die immediately if there's something wrong. Oh, no, not something wrong. It's the process end. Okay, of course, something wrong in the middle. I already give an exit there. Now the problem is, after this, I didn't handle zombie. Okay, maybe you can think of any ways to implement it. Go ahead. But in assignment 1, okay, we want you. You know why I don't write it? Because I know that it's troublesome. Okay, why is troublesome? Can a parent call waits? No, waits is blocking system call, right? If a parent call waits, can I call accept? Okay. It is also ridiculous that you fork a process to call wait. What is that concept? Okay, basically it's totally wrong. Okay, so I know the process is very troublesome. Basically, I need to do some unblock waits. Okay, so I don't like you to have this challenge. Okay, that's why in the assignment I will change it into prefab. Okay, prefab basically you can avoid all the trouble. Okay, but the only trouble is if you have a segmentation fault, all thread dies. Okay, so you will need to be very careful. Now I finished most of the programming overview, okay, of the parallelization of the server. Now, how about client? Client, do you need parallelization? It depends on the application. If your client need to connect to multiple hosts, okay, or multiple connections to the same host, then you need parallelization. If not, then you don't need it. Okay. So for the client, it's not matter whether you do fork or prefab, but in a server you need fork or prefab. Usually you need it because most of the protocol or most of the network communication is round based. Okay, round one you talk about what you want, and the server gives you a response. And round two, the server tell you that something coming. I give you all the packets. I give you all the data. So it is a kind of interactive, but without a human interaction. Okay. Any problem? Any problem you want to ask? This is already very fast, I would say, because it didn't write the code. Okay, I give you the code, you look at it, oh, seems to be okay. Seems to be okay. Then I ask you to write it from scratch, then you all die. Okay. Any problem? No? Go ahead. This is a very tricky slide. Okay. Every year I spend at least 15 minutes to explain this, and every people just sit here, what you're talking about. Okay, so what is this slide about? Okay, look at that for a while. Tell me what is the purpose, and what is that question mark? Oh, by the way, if your last semester assignment 2 is using a read-write system call to do the process read-write, that will be beneficial. If not, you can still some think about it. I give you 1 minute. Tell me what this program is doing. Seconds. You can assume that I didn't use a file redirection. It's always standard I/O, okay, using a keyboard and screen. I didn't give you a program, okay? I want you to write it. Okay? Send me a message. So, what this program is about? Any idea? What this program is about? I have an offer to get your input. The size is 10, right? And I do a while loop. Okay, will I break it out? Will the loop stop? Yes, the loop will stop, but when? But when this loop will stop? Until what? And then we have just a laser. So the loop is here. Will the loop stop? Or I should say, let's say the loop won't stop, okay? So what is the purpose? The purpose is scan something from a sender in, okay? And ask for how many bytes? 10 bytes. Okay, ask for 10 bytes, read it into the buffer from the keyboard, and then what? And then printf saying that what is the return value. I don't know whether you have checked the return value in assignment 2 of operating system. If not, then it will be a big problem. Okay? So the return value is very important to tell you what? To tell you how many bytes the read system call found from the input. Okay? And let's say it won't break out, okay, then I will have a write system call, write to where? Write to the screen using the buffer content. Now tell me what should be this question mark. Putting 10. I have a 10 byte buffer. I should write 10 bytes out. No. So what is that? 2, 1, 0. RET. Good to say RET here. Okay. RET. Why? Why RET?
Otherwise, you write some useless symbol.
Useless symbol. So let me revise the problem. So how to revise the problem? The problem goes back. Okay, let's say if you believe him that it is RET. Now let me roll back. Why this RET return value won't give you 10? Right? I asked for 10 bytes. Why don't you give me 10 bytes? Oh.
Because the user may not enter 10 bytes.
Again?
The user may not enter 10 bytes.
Good. The user may not enter 10 bytes. Okay? So let me demonstrate it. Okay? So on purpose, I don't write this program because I want you to first we discuss it about. Oh, what is it? Python. I want you guys to understand the purpose first. Then I will write the program now. So believe in me. Okay? Although I get a back ranking in a hacker club, still typing fast. Okay, so let me save it first. Let's call it a test.c. Okay, so I have a buffer, 10 bytes. Okay, so the return value, of course, while1. And then let's say the while1 is, later I will tell you why sometimes it's a negative number. So it is break, remember the component. Then RET equal to read from the buffer. Oh, no. Read from the file number standard input. And into the buffer, I ask for 10 bytes. Okay, so of course I need to tell people that what is the value of the RET. So RET. Then last I will write to the screen. Okay, so that it is a file number standard output. Okay, so believe in them. Okay, RET. Good. Anything missing? Okay, maybe I also print out a by here so that you know that the program dies. Okay, no problem. Any problem? Yeah. Okay, so no, it's just here. So the test.c is here. I just created make test. No, oh, I'm too lazy. Include Unix standard.h. Good. Okay, so run. I type something first. Hello world. Hello world. Okay. Enter. What will happen? How many bytes I have to input? 11. No, 12. There is the enter. Okay. Now when I press enter, take a look. The first 10 bytes, okay, the first 10 bytes is being output, okay, so where are they? It returns 10, the resistance code is like this. If you ask for 10, but the buffer or the input is more than 10 bytes, okay, it will give you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is the end. Okay, so because the 10 bytes I just outputted and without appending an enter, so you will see RET append here. And then RET, the remaining 2 bytes, okay? And why is say 2 bytes? Because the stream already get ready there, okay? So the return value of 2, okay, doesn't mean that it is the end of the stream, okay? Because I can still continue it. Let's say the bye-bye, I have bye-bye, okay? It knows there is 7 bytes. So the Anderson stream that stop there if it don't return 10. Now this is a standard input version. Now how about networking? The same. It is the same. Okay? So the networking thing is you ask for data, okay? Ask for a piece of data. Let's say again it's just copy and paste what happened here. I ask for 10 bytes. Okay? I remove all the opening of the socket, connection, blah, blah, blah. I only leave a read and write here. They are still the same. But I just change this into the socket. Now the problem is this. If you ask for 1,000 bytes, it sometimes don't give you the 1,000 bytes. Okay? If you ask for 1 million bytes, it's usually certainly don't give you 1 million bytes for the read system call. Okay? It will just give you partial things. And what should you do? Let's say your message, okay, I need to read up to 10 bytes so that I know what to do. Okay, let's say the command that you design asks for 10 bytes. If you don't have 10 bytes, you have to continue until you have 10 bytes. Okay? So what does that mean? That means that there's a source of bug. If you say that, okay, I put a read system call there, I ask for 10 bytes, I always believe that I will have a return value of 10. Okay? And you never check the return value, then boom, you will have a bug. Okay? So this is a precaution, very, very important precaution here. Remember this, don't trust the value that you ask for. Okay? Your value is asked for is the upper bound. It's the upper bound. I will ask for 10 bytes. You have seen this before, right? I type hello world, enter is 12 bytes. Exceed the upper bound, okay, I give you 10 bytes. How about remaining 2? Wait for the next read system call. Okay? So that means that if you ask for a certain kind of value, remember, write a while loop to do countdown. Okay? How many bytes is remaining? How many bytes is remaining? Okay? Our tutor will talk about it. Okay? But I don't believe that the tutor will tell you the reason behind. Okay? This is the reason behind. Okay? Tutor will always give you the call. They name it very strange. The name is called receive n. Okay, receive up to n bytes. Okay, they give you a function already. Okay, before you see their functions, okay, you know, understand now. Oh, this is the purpose. Okay. So this is a very important thing, and it's happened all around. Okay, happen in I/O, basic I/O like the standard input, standard output. Okay, or another call that is tailor-made for networking called receive. Okay, they also have some problem like this. Okay, so any problem about programming. Okay, I don't think that it's only a C problem. It is problem for every programming language. Okay, it is because this is the problem of socket. Okay, let's say I can in a test case. Okay, while you're doing demonstration, I do the following thing. Okay, I really do that. Okay, while I was the TA is really being queued by every student because every student is spoiled with this crap. Okay, what is the test case? My server will do this. Okay, you ask for 10 bytes. Okay, every time send 1 byte. Sleep for 1 second. Okay, 1 byte, 1 second, 1 byte, 1 second, 1 byte, 1 second, so that I can have a stopwatch. After 10 seconds, your program should give me response, but usually not 10 seconds. It's 0.1 second, and boom, it suddenly gives you response, and the response is segmentation fault. Okay, because it's only receive 1 byte, and the 1 byte you didn't check the return value and believe the buffer contains all the things you have, then you process the buffer, die. Okay, usually 0.1 second segmentation fault. Why my program have problem? In my home, no problem. Okay, yeah, because I do it on purpose. Okay, so any problem? If no problem, we go back to the high level things. Okay, any problem? If you have any problem, stop me. Okay, if you want to have some time to verify some of the codes, okay, I can give you the time during the break. Okay, or you find some problem during the break. Okay, you can ask me as well. Now we go back to the high level concept. Now the high level concept is that although we do a top-down approach, we talk about applications and then TCP, UDP, and then IP, but sometimes we cannot skip the low-level things, okay? Because we want to talk to a target, usually we will use their low-level address, okay? So what is the low-level address I'm talking about? It's the IP address, okay? Now usually I remember this, okay? 191.192 because I do some testing, okay? So what is this? This is our www.csd.chk.edu. Okay? So now the problem is, later on I will also talk about what is the meaning of having a service you can detect whether it's live or not, okay? So let's say in this server, CSD web server, it basically provides several services. I believe they should have not a telnet, but a SSH service, right? Because our admin needs to debug, okay? Need to debug. Oh, there's something happens, okay? I can SSH to the server. So at least it's open an SSH server. Of course, this is a web server, so at least it will open HTTP, HTTPS. So HTTPS is another service. So one is a normal web, is another secure web. So how can a client can identify that? So very easy. So we will use a port number. Okay, the port number while the process just start. Okay, by the way, there is a range of port number that is requires the root account to bind it. Okay, so what is the range? Is from 0 to 1023. Okay, you need to use a root account to bind it. So let's say these two servers actually we use a root to start it. Okay, and the root to start it, basically you can bind this small number port, 22, 23, 80, so on and so forth. If you're interested, you can look at this file by yourself. I will also show it now. What is this file? This file is very interesting. Okay. So what is that? Can you read the comment? The comment says that network services internet type. This is already a port assignment. Okay. What is port assignment? Usually this is a tradition. Okay. It doesn't say that. If you say that this web server, I don't want it to be port 80, I want it to be port 12345. You're against some rule and the system stop you. No. It's just tradition. Okay, the tradition is that there are port assignments, and assignment tradition is documented in this file. Okay, so it already say that the well-known port is from 0 to 1023. So they are important services. Usually need the root privilege to bind it. Okay, for others, okay, you are feel free to bind it. Yeah, what are they? Let's look at some famous services. They are not famous to you, but at least famous to me. Here. Can you see some famous name? How many can you name it? What is the port number of FTP? FTP, where is it? 21. Okay, so that means that when I talk to port 21 of an FTP server, I should get some response. Believe it? Let's try it. Telnet ftp.chk.e.hk port 21. So immediately our university web server and FTP server responds to me. And this is not the response that I type. I just connect to that port. Immediately the FTP server tell me something. Okay? So I need some other command to go on, but I don't want to do it now. Okay, so quit it. What are the remaining important servers? SSH, right? Now let me try that. How about I do something crazy? Telnet. I don't try public service. Okay, I don't know what will happen. Okay, so maybe my own machine. And then port 22. So why is port 22? Here, I don't know, here. Okay, SSH is for port 22. Can you see this? Immediately the server gives you another response. The server gives you the response that, hey, he is SSH 2.0 version, open SSH, right? So how about others? How about others port you can think of? How about remote desktop? What is remote desktop port number? I can't remember. Free what? Free. I can't remember. Remote desktop. Remote. No. 3000 something. I remember. Hey, come on. Wow, 有冇咁多? 3000. Wow, 咁多嘅. What is the name? I can't. Remote. I remember it's not called remote desktop. It's called 3乜嘢啊？338乜啊？389? Oh right. It's called, I don't know what it says. Microsoft WBT or I don't know why it's called WBT server. Okay. So how about another one? Another is called 443. 443. Okay, oh sorry. This is go back to the top. 443 HTTPS. I said that our course is very secure. Okay, so how about others? 445 is another famous port. Okay, it is what we call a Microsoft domain name service or name service. Okay, it's basically a use this port to look for what is the host inside your mono. Yeah, network neighborhood. Not what neighborhood is using this port number. Okay, if you block this port, you cannot mount any drive. Okay. So how about others famous port? What are the famous software you're using? I don't answer LOL. I don't think there is there. Okay, or maybe a database. Okay, who took a database course last semester? Oh, this Custer. I am instant instant manager. I think it's instant message. This is the port when you type SQL -u blah 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 blah. You connect to a server. So it's use this port number if you're talking about talking to a foreign server. Okay, so that means that every server has a well-known port. Okay, whenever you install a software, usually if you use this well-known port, you cannot, usually cannot buy it using an ordinary account. But let's say I want to have another Apache server. Apache is a web server. I want to have another server bind to another port that I want to hide from other people. Okay, you are welcome to do it. Okay, let's say I love to buy my service like I don't tell you the port number. Okay, I buy my remote desktop. Okay, of my virtual machines. Okay, there is a virtual machine hiding in my office. Okay, which is a window. Okay, I open a port which is not 3389, so that's why I always forget it. Okay, I buy to another port number. Okay, so that no one knows that I'm opening a remote desktop. Okay, I change the port number like this time